All right, are you ready for some serious engine electrical systems test prep?
Yeah, let's do it.
We're going to cover a ton of stuff today, going way beyond just the simple answers.
We really want to make sure you understand the why behind it all.
Exactly. So
Hmm.
you're not just memorizing facts. You're really getting it, you know?
It's about building that solid foundation.
Right. And to help us unpack all this, I've got a true electrical systems expert here with us.
Happy to be here, ready to dive in.
Awesome. So let's just jump right in.
It sounds good.
Okay, let's say you come across a question about circuit protection,
Okay.
specifically those manual resets. Why are the regulations so strict about that? You know?
Well, it all boils down to safety.
Safety, okay.
Imagine you have a circuit breaker that just resets itself automatically.
Hmm.
You might never know there's a problem.
Oh, that's a good point.
Yeah, manual reset forces you to stop and figure out why that circuit tripped in the first place.
It's like a built-in reminder to be thorough.
Exactly.
Like, let's say an overheated wire is causing the problem. You need to fix the wire, not just ignore it.
You got it.
Okay, so it's all about addressing the root cause.
Absolutely.
Now, are there any exceptions to this rule? Like, are there any circuits that don't have a fuse or a breaker?
You're thinking like an electrician already? There's one major exception, starter circuits.
Starter circuits, okay.
Yeah, when you're cranking the engine, the current draw is massive.
Ah, I see.
A fuse would just blow right away.
So it's about getting that engine started as quickly as possible.
Exactly. The priority there is speed.
Okay, that makes sense.
Okay.
All right, let's shift gears a bit and talk about wire gauges.
Okay.
You know, those charts that show how much current a wire can handle.
Yeah.
How does that translate to a real aircraft scenario?
Well, think about it like this. You're wiring up a landing light.
Okay.
You need to make sure the light is bright enough
Got it.
and that you don't have too much voltage drop
Mm-hmm.
that could cause the light to be dim or weak.
So the chart helps you pick the right wire gauge to avoid those problems.
Yeah. Exactly. It's all about efficiency and making sure everything works as it should.
Okay, that makes sense. Yeah. Now let's talk AC and DC systems.
All right.
What are the big advantages of using AC, especially in those larger aircraft?
AC allows you to step up the voltage using transformers,
Okay.
which means you can use smaller, lighter wires for those high-power applications.
So it's all about weight savings.
Absolutely. Weight is a huge factor in aircraft design.
Makes sense. Lighter plane equals better performance.
Exactly.
Now let's say there's a question about flashing the field of a generator.
Okay.
What's that all about? It sounds kind of intense.
It's not as dramatic as it sounds.
Okay.
Basically, it's like jump-starting the generator.
Jump starting go.
Over time, the generator's magnetic field can weaken.
I see.
Flashing the field restores that magnetism so it can start producing current again.
So it's like a little reminder for the generator.
Yeah, you could say that. Haha.
Okay, so besides flashing the field, what other components are crucial for keeping that generator output stable and protecting the system?
You've got the voltage regulator.
Okay, the voltage regulator.
It keeps the output voltage within a safe range.
So it's like a safety valve,
You got it.
preventing too much or too little electricity from flowing.
Exactly.
What else?
You've also got the reverse current cutout relay,
Okay.
which prevents the battery from trying to power the generator.
Oh, that makes sense.
And of course, you have the master switch.
Yeah, giving you manual control over the whole system.
Right, it's like the main power switch.
Okay, so it's like a team effort keeping everything running smoothly.
You could say that.
All right, let's move on to electric motors.
Sure.
When it comes to starter motors, what type should we focus on?
The workhorse of the starter world is the series wound DC motor.
Series wound. Okay.
They're known for their high starting torque.
So they can really crank those engines.
Exactly. They've got the muscle for the job.
Okay, so are all the motors in an aircraft series wound?
Nope, not at all.
Okay.
You'll see other types like three-phase induction motors
Mm-hmm.
and capacitor start motors.
Okay.
Those are typically used for things like pumps, actuators, and fans.
So different motors for different tasks.
Exactly the right tool for the right job.
Okay, that makes sense. Before we wrap up this section, let's talk about batteries.
Nice.
If there's a question comparing lead acid and nickel cadmium batteries, what's a key maintenance difference?
With lead-acid batteries, you got to be really careful about keeping them charged,
Okay.
especially in cold weather.
Cold weather. Why is that?
If they get too discharged, the electrolyte can freeze, and that can damage the battery.
So it's not just about performance. It's about protecting the battery itself.
Right.
Now, what about nickel-cadmium batteries? Any special charging tips for those?
They prefer a constant current charging method.
Constant current. Okay.
It helps to keep all the individual cells balanced.
So it's like giving them a balanced diet.
Uh-huh. Yeah, you could say that.
All right. I think that's a good place to pause for now.
Sounds good.
We've covered a lot of ground, but there's still plenty more to explore.
Absolutely. We'll pick up right where we left off next time.
All right, so until then, keep those circuits flowing and those brains charged up.
Haha, will do. All right, ready for round 2?
Let's do it. Let's talk about wiring and installation.
Okay.
What's one crucial thing to remember when you're routing wires near fuel lines?
Safety first, always. You always want to route those wires above the fuel lines. That way, if you have a leak, the fuel won't drip onto electrical components.
Oh, that makes sense.
You don't want fuel and electricity mixing.
All right, fire hazard.
Exactly. It's all about preventing potential problems.
Okay, so thinking ahead, now what about those terminal studs?
Okay.
You know, where multiple wires connect. Are there any limits on how many wires you can put on one stud?
Good question. You should never connect more than 4 terminals to a single stud.
4. Okay.
Yeah, too many wires can lead to poor contact, and you can overload that stud.
It's like trying to plug in too many things at once.
Exactly.
Okay, speaking of connections, what about bonding jumpers?
Bonding jumpers. Those are important.
Yeah, what are they exactly, and why are they so important?
Think of them like little safety valves for your electrical system.
Okay.
They create a low-resistance ground path throughout the aircraft structure.
I see.
So if there's any stray current, the bonding jumper gives it a safe path to flow to ground.
So it's like a backup plan for those unexpected currents.
Yeah.
You could say that. Okay, so it's all about keeping things grounded. Now, even with good wiring and connections, there's always going to be some voltage drop, right?
Right.
How much is acceptable between the generator and the bus bar?
You want to keep it to less than 2% of the regulated voltage.
2%. Okay.
If it's more than that, you risk those electrical components not getting enough power.
So it's like a water pressure drop in your house.
Yeah, kinda.
Okay, so we need to make sure those components are getting enough juice. Now let's talk about connectors. Are there any specific installation tips for those pin and socket connectors?
This is a good one. You always want to install the pin section on the ground side of the circuit,
Okay, on the ground side, why is that?
so that when you disconnect the connector during maintenance, those exposed pins aren't touching a live voltage source.
Oh, that's a good safety precaution.
Exactly. It helps prevent sparks and potential shorts.
So it's like a built-in safety feature.
Here.
All right, while we're talking about maintenance, what about those commutators and slip rings?
Oh, yeah, those are important too.
Yeah, what's the best way to keep them clean and in good condition?
The source material recommends using 00 sandpaper.
00.
Okay. Yeah, it's fine enough to remove any dirt or oxidation without scratching the surface.
So it's like a gentle cleaning.
Exactly.
Okay. And what should we avoid using?
Never use anything conductive like a metal file that could
Right.
create a short circuit between the segments.
Right. So stick to the 00 sandpaper.
Okay.
Yeah. Now let's switch gears a bit literally.
Okay.
If we have a question about selecting switches for DC motor circuits, what do we need to remember?
You got to dehydrate those switches.
Regen. Okay.
Yeah, DC motors draw a huge amount of current when they first start up.
I see.
You need a switch that can handle that initial surge.
So it's like choosing a strong enough rope.
Yeah, that's a good analogy.
Okay, so you're building in that safety margin.
Yeah.
Now, are there any standard practices for installing those engine control switches?
Good question. For engine controls, forward or upward movement should always mean on or increase.
Oh, okay, that makes sense.
Yeah, it's a visual cue for the pilot, so consistency is important.
So up for on, down for off, kind of a universal language.
Exactly.
And what about those trip-free circuit breakers? They sound serious.
They are trip-free circuit breakers, can't be manually held closed if there's too much current flowing.
Oh, wow.
They'll chip open no matter what to protect the circuit.
So they're like the ultimate safety feature.
You got it.
All right, let's dig a little deeper into AC generators. Those are also known as alternators, right?
Right.
What are some key things to remember about those?
Remember the relationship between the generator's speed, the number of poles in its magnetic field, and the frequency of the AC output.
Okay, speed, poles, and frequency.
Exactly. The faster the generator spins and the more poles it has, the higher the frequency.
And most aircraft electrical systems use 400 hertz AC.
That's right.
So it's all carefully calibrated.
Exactly. And those constant speed drive units we talked about earlier help maintain that 400 hertz frequency even when the engine speed changes.
So it's like a built-in metronome.
Yeah, you could say that.
Okay, what about DC generators? Anything specific we should focus on there?
The voltage regulator is key.
The voltage regulator, okay.
It keeps the output voltage stable, even when the load or speed changes.
So it's always adjusting to keep things running smoothly.
Exactly.
Now remember that flashing the field process.
Yeah.
Why wouldn't you need to do that on a brushless alternator?
Because brushless alternators have permanent magnets in their field poles.
Ah, so they don't need that extra boost.
Right, they're like self-starting generators.
Okay, that's pretty cool. Now back to batteries. What's that ampere hour rating all about?
The ampere hour rating tells you the battery's capacity, how much current it can deliver over a certain amount of time.
So it's like the fuel tank size for your electrical system.
Yeah, that's a good way to think about it.
Okay, so a higher rating means more electrical fuel. Now, we talked about lead-acid batteries and keeping them charged to prevent freezing. What about nickel-cadmium batteries? Any other maintenance tips?
Keep them clean and dry.
Clean and dry. Okay.
Yeah, moisture can lead to corrosion and shorten their lifespan.
Got it. So protect them from the elements. What about charging them? Anything else to keep in mind besides that constant current method?
Don't overcharge them.
Okay.
Overcharging can cause them to overheat and mess up the balance of the cells.
So charge them fully, but don't go overboard.
Exactly.
Okay, good advice.
Oh, yeah.
Now let's switch gears again and talk about regulations and documentation.
Right, the paperwork.
Yeah, We got to make sure we're up to speed on that stuff too.
Definitely. You'll want to be familiar with 14 CFR Part 91.
Okay, Part 91.
Yeah, it covers general operating and flight rules, including the requirements for spare fuses.
Oh, yeah, I remember seeing a question about that. How many spare fuses do you need to have?
Part 91 says you need either one complete spare set of fuses or 3 spare fuses of each kind required.
Okay, so you got to be prepared.
Always. It's like having a spare tire in your car.
Right, you never know when you might need it. Now, what about those other regulations like Part 23 and Part 43? Should we brush up on those as well?
Absolutely. Part 23 covers airworthiness standards for airplanes.
Okay.
And Part 43 deals with maintenance and alteration.
So those are like the rule books for aircraft electrical systems.
Exactly. No shortcuts allowed.
All right, let's talk about some specific electrical components.
Okay.
What about relays?
Relays are like electrical messengers.
Messengers, okay.
Yeah, they use a small current to control a much larger one.
I see.
They're used for isolating circuits, providing safety interlocks, and activating high-power devices.
So they're like the control center of the electrical system.
Yeah, kind of.
Is there a particular type of relay that tends to show up on these tests?
Starter relay is a common one.
Starter relay.
It handles the heavy current needed to crank the engine.
Ah, so it takes a lot of the load.
Exactly. It protects the ignition switch from those high currents.
Okay, that makes sense.
Thanks.
What about diodes? I remember those being important for something.
Diodes are like one-way valves for electricity.
No-way valves, okay.
Yeah, they only allow current to flow in one direction.
I see.
They're essential in rectifier circuits, which convert AC to DC.
Right, so they're making sure the electricity is flowing the right way.
Mhm.
And why is the rectifier so important in a DC alternator system?
Because alternators naturally produce AC, but many aircraft systems need DC power.
Ah, so the rectifier is like the bridge between the two.
Exactly. It makes sure the power's compatible.
Okay, that makes sense.
Yeah.
Now let's shift gears one last time and talk about troubleshooting.
All right.
We talked about some basic tools earlier, but what about those really tricky problems? What are some more advanced techniques we should know?
When you're dealing with a complex electrical problem, the first step is to gather as much information as possible.
Okay, so don't jump to conclusions.
Exactly. Talk to the pilot, review the maintenance logs, and carefully observe what's happening.
So it's like detective work.
Yeah, kind of.
Okay, so gather the clues. Then what?
Then you can start isolating different parts of the system to try and pinpoint the fault.
So it's a process of elimination.
Right. And remember to document everything as you go.
Document. Okay.
Yeah, it's like leaving yourself a trail of breadcrumbs so you don't get lost.
Good advice. So what are some of those advanced techniques you mentioned?
One is voltage drop testing.
Voltage drop testing, okay.
It helps you find excessive resistance in a circuit.
How does that work?
You measure the voltage across a component or a wire. If the voltage drop is too high, there might be a loose connection, a corroded terminal, or even a damaged wire.
So it's like checking for clogs in a pipe.
Yeah, it's a good analogy.
Okay, so it helps pinpoint those trouble spots.
Yeah.
What about current tracing? That sounds pretty high tech.
Current tracing allows you to measure the current flowing through a wire without interrupting the circuit.
Wow, so you can actually see the electricity moving?
Well, not literally see it,
Okay.
but you can measure it with a special tool called a current probe or clamp meter.
So it's like X-ray vision for electricity.
Yeah, something like that.
Okay, and what about load testing?
Load testing is like a stress test for the electrical system.
Okay.
You apply a controlled load to see how a circuit or component performs under pressure.
I see, so you're looking for any weaknesses.
Exactly. It helps prevent potential failures before they happen.
So it's a proactive approach.
Right.
That's a lot of information. What's the most important takeaway from all this troubleshooting talk?
Be systematic and logical.
Okay.
Don't rush gather information, isolate sections of the system, use your tools effectively, and document everything.
Great advice. And speaking of advice, what's one final thought-provoking question you want to leave our listener with?
We've talked about all these individual components, generators, batteries, wires, switches, but how do they all work together as a complete system to keep that aircraft flying safely and reliably? What happens when one part of that intricate web fails?
Wow, that's a great question. It really makes you think about the bigger picture.
Exactly.
Yeah, it really does. It's like a whole ecosystem, you know?
Yeah.
Now, before we wrap up our test prep session, I wanted to touch on inverters.
Okay, inverters.
They seem to be a bit of a mystery for some people.
Yeah, they can be a little tricky.
What's their main function in the aircraft electrical system?
Basically, inverters do the opposite of rectifiers.
Opposite, okay.
They take DC power and convert it to AC.
Ah, so they're like the flip side.
Exactly.
Now, why would you need that if a lot of the aircraft runs on DC?
Well, some systems actually require AC power.
Oh, I see.
Things like passenger entertainment systems with their screens and outlets, or some avionics equipment.
So it's about having the right type of power for each system.
Right, different systems, different needs.
Okay, that makes sense. What about static inverters? I've heard that term. What makes them special?
Static inverters are kind of the modern high-tech version of inverters. They use semiconductor devices like transistors to do that DC to AC conversion.
So they're more efficient?
Much more efficient and reliable than those older designs.
Oh, okay.
The ones that used mechanical components.
So it's like the difference between a hard drive and a solid-state drive.
Uh-huh. Yeah, kind of.
Okay, so quieter, faster, less wear and tear.
Exactly.
Yeah.
And they often have sophisticated control circuitry to regulate the output voltage and frequency very precisely.
Ah, so they're not just converting the power, they're making sure it's high-quality power.
Right. Clean and stable power for those sensitive electronics.
Okay, that's really important.
Okay.
Now, before we wrap up completely, I wanted to touch on troubleshooting those really tough electrical problems, you know, the ones that make you scratch your head.
Haha, yeah. Those can be frustrating.
Any final words of wisdom for our listener out there who's facing those tricky test questions?
Just remember to stay calm, think logically, and use all the tools and knowledge we've talked about today.
Okay, stay calm, think logically.
Don't be afraid to go back to basics. Check those connections and really try to understand how the electricity is flowing.
So it's like a puzzle.
Yeah, you gotta piece it all together.
And if you get stuck?
Don't give up. There's always a solution.
Right, persistence is key.
And sometimes that journey of figuring it out is the best learning experience.
That's so true. Well, I think we've covered a ton of ground today, from those basic concepts to some pretty advanced stuff. I'm feeling pretty confident that our listener is ready to ace that test.
Me too. I think they've got all the tools they need.
And more importantly, they've got the knowledge and the mindset to approach any electrical challenge with confidence.
Absolutely. That's what it's all about.
Well, it's been awesome having you here today. Thanks for sharing your expertise.
It's been my pleasure. Happy to help.
And to our listener out there, best of luck on that test. You got this.
You got it.
Until next time, keep those circuits flowing and those brains charged up.
Haha, will do.